If you're gone this far, you're doing great. Levels 4 and 5 have a lot to do with meiosis. We're going back to meiosis, this idea that chromosomes are going to be sorted randomly. And that's going to be a key for levels 4 and 5, this kind of random sorting of chromosomes. We're going to see it here whenever we get a sperm from the man, female from egg from the female, and we're combining those two. But the chromosomes that are in the sperm and egg are going to be carrying traits. Those traits are sorted randomly. Those alleles are sorted randomly. So whenever you're looking at something like this, remember, you don't need all of those alleles to be dominant. They could be, some of them could be recessive because you're trying to get the fewest moves possible. Also, remember that it's going to be random. So there's some random sorting that's going to happen here, and that can get a little bit frustrating. What you're observing are these two principles in action. First is the principle of segregation. That means that each parent only gives one allele, not both, just one allele. The other principle is independent assortment. That means certain traits do not influence other traits. That's different than the epistasis we saw earlier. In this case, just because you have wings does not mean you have arms. You could have wingless with arms, wingless without arms. Just as easily as you could have wings that have arms and wings that have no arms. The problem is when you're getting two recessive traits together, the probability of that is 1 in 16. So it's kind of small, which means you might have to breed a lot of dragons before you get the traits that you're looking for. The other characteristic that you're going to see show up here are sex-linked traits. That is, traits that are carried only on the X chromosome. They are not carried on the Y chromosome, so they're sex-linked. They're linked to sex, the sex chromosomes. For example, color blindness in humans. Color blindness is a recessive trait. You'll notice it's carried on the X chromosome. That means the mother, in this case, is colorblind, the father is normal. The girls are not going to be colorblind. They're carriers. The boys are going to be colorblind because they get the X from the mother, only a Y from the father. So pay close attention to how that Punnett square works, because when you're looking at these dragons and you're trying to get a trait on a male, it's going to be way more frequent than a trait on a female, because to get the trait on the female, you're going to need 2 recessives. To get the trait on the male, you only need 1. So pay close attention to that, because you're going to have some of those cases. Whenever you're doing something like this or test crossing with some traits like this, I click that breed button a lot of times, because sometimes those traits I'm looking for are going to be so improbable, I'm going to need to breed lots of clutches. The other thing is, if I don't know what the parent's genotype is, but I do know what the offspring are, I'm going to breed that unknown parent with one that is completely recessive, has the most recessive traits possible. I say most recessive because of things like multiple alleles or things like incomplete dominance. I want the most recessive trait to be on the one that I know, so that I can see, based on the probability of the offspring, whether it's 100% a certain trait, 50% of a certain trait, 75%